Today I would like to talk about this new service we launched just at reInvent last year. And our goal is to easily develop, test, and deploy intelligent robotic applications. So today we will be talking about multiple things. So why we chose to build AWS RoboMaker. So one, for accelerating robot validation, for simplifying robot development, and to ease fleet management. So, and today being at OSCon, I would also like to highlight the kind of open source software we are using to build AWS RoboMaker and provide those features to our customers. So first, why did we build AWS RoboMaker? So if you look at this slide, you will see that obviously robots are coming in different shapes. You may have humanoid robots, you may have drones, rovers, like robots for education, for logistics. And they all seem very different, but they share a lot of common problems. Well, you need to care about telemetry data, you need to care about your kernel, you need to care about security, privacy. And even now, for a lot of robotic startups, all of those building blocks are built from scratch. And here at AWS RoboMaker, we are wondering, what if we could provide services to those robotics companies, building blocks, so that each robotic startup or company does not need to reinvent the wheel? To do that, let me just talk for a while about why is software for robots different. So when you build software for a robot, basically, you need to integrate with a lot of hardware. So what will happen is that we'll have sensors like LiDARs, cameras, IMU units. So those will perceive the world around you. So all of this data is sent to your software stack, which is going to generate a motion. And this software stack is on the other side talking to more hardware, which will actually execute this motion. Robots evolving in physical worlds, all of that is going to impact your environment, and that's how you close the loop. So your sensors will now perceive a changed world, and you iterate until you realize the task. Okay, let's dig a bit into what's happening there. So a bit in a similar way that what you would have in the cloud with microservices. So roboticists want to separate concerns into multiple components. So here what you can see is that we'll have drivers on the left and on the right of this orange box. Those drivers are just here to communicate with the hardware, and then each algorithm will be a different component. So it's interesting because you can be more reliant to crashes, to problems with your architecture, and it nicely separates concerns between different parts of your stack. You may separate your motion planning from your trajectory execution stack and so on. So it's great, but it introduces a requirement. You need now message passing to properly divide those components into multiple processes and let them talk with each other. So the question is, how do you do that? So usually, people would use a pub subsystem. So that's where open source software is coming into play. So you don't really want to be stuck into a proprietary framework to develop those components, because it prevents you from, for instance, contributing your own improvements. So the first feature that AWS RoboMaker wants to help robotics companies with is helping you validate your robot. So you may have seen, if you look at self-driving cars nowadays, or many kind of robotics, a very challenging part of building robots is actually validation, making sure that it's going to do what you want, that independently of the kind of environment you're in, it's going to produce the right result. So why is it hard? Well, it's a hard problem for many reasons. So, for instance, if we were to compare to a cloud API, well, first, software input validation is very challenging. So if your input is an image, well, you're receiving unstructured data from your environment. So it's very hard to make sure that this image will not break your system. So it's uncontrolled and it's hard to reproduce. So if you are dealing with a logistic robot and suddenly the navigation stack or the perception stack breaks because there is a reflection of the sun on a window, then you may retry the same scenario 30 minutes later and you will not achieve the same result. The software is tightly coupled to hardware, and it's dependent on a large number of parameters. So it makes testing very hard and time-consuming. So if you compare to a cloud service, where your cloud service, well, you can start dogfooding, it's going to serve many users at the same time. It's going to help you actually find bugs very quickly, while your robot, your software for your robot needs to run on the real hardware, and you probably have only a few robots at hand, and each robot can execute only one task at one time. So finding bugs is a sequential process, and it's very hard. So the solution we have is to build AWS RoboMaker on top of open source software. So that's where ROS comes into play. So ROS, the robotic operating system, is providing a system for message passing and a way to define robotic components for your robot. So it's purely open source, it's BSD licensed, it supports many languages such as C++, Python, it's under heavy development, so OSRF, the company developing ROS, is now developing the second version of this middleware, and because you now have a way to actually define your components, well, some interesting things start to happen. Well, first, you start bootstrapping an ecosystem of robotics components, which again didn't really exist before ROS. Like, all robotics companies were really starting from a blank page, but now, because you have a way shared across the industry to build robotic components, then now you can reuse perception stack, you can reuse navigation stack, and this is really helpful to any company doing robotics. The second part is that because now you have this single place where people are collaborating, then you can start investing into developer productivity tooling. So ROS is well known to provide capacities around message recording and replay, because again, it's hard to reproduce problems on robots. And it's also providing visualization tools. It's very important for robotics because roboticists are mainly dealing with physical quantities, images, numbers, which has physical meaning, and you need some kind of 3D interface to, for instance, plot your robot configuration or its position and so on. So all of that is provided by ROS. And we can even go more than that. So OSRF is also developing a simulator called Gazebo. If we go back to the initial diagram, you can see here that your orange box becomes a system under test, and what you want is to validate that it's doing the right thing. So you want to abstract away all of your hardware to make sure that, well, you can scale it, and you don't need to actually take the risk of, for instance, breaking hardware when you validate a new version of your software. Well, again, because you have this generic message passing infrastructure, then you can cleanly mock out your drivers, both on your sensor part and on your actuator part, and it allows you to basically safely test the new features that you want to deploy on your robot. So that's really great. Open source has been maturing a lot in the robotics community in the past few years. But how can we go and do more than that? And that's where AWS RoboMaker comes into play. So what we're providing is, on top of ROS and Gazebo, simulation as a service. So the problem we heard from customers is that, well, Gazebo is a desktop software, and being a robotic company, what you really want is a continuous integration pipeline. You don't want necessarily your engineers to run those simulations on a local workstation. So you can come, take your currently existing Gazebo simulation and run it on the AWS infrastructure, which gives you all the benefits you're all accustomed to, which is you can scale easily. Like, let's say you're just like releasing a new product, then you can run thousands of simulation at the same time. It's a pay-as-you-go model. You don't need to actually maintain all of this infrastructure in-house. And of course, because it's happening in the cloud, all of the simulation results are going to be stored in S3 buckets and or in CloudWatch, so it will allow you to run offline analysis and run things like A/B testing. So that's one service we're providing, and you can see here that by leveraging the power of open source software, we can bring like a real value to those robotics companies who now have an easy way to write end-to-end testing for robotic products. Another axis we want to look at is simplifying development. So something which is very challenging for the robotics community is that it's too hard to develop robots. So why is it too hard? Well, because you really need to maintain the whole stack. So you start by choosing a platform, interfacing with hardware, implementing complex algorithms, choosing a way to do your message passing. Well, on top of that, because it's a robot, those are numerical algorithms running on an embedded platform, then you have constraints in terms of performance, latency, safety. You don't want the robot to break itself or to damage in its environment. Well, and on top of that, that gives you a platform, but you're not really having a product yet. If you want to have a product, then you need to add on top of that the business logic. What is a useful task that the robot will do on top of, let's say, move around in a room? You will need to start caring about fleet operation. If I have now hundreds of robots deployed in a factory, then I need to start caring about battery management, about how I will do over-the-air update. And obviously, security, user data privacy is also coming into play. So all of that is very hard. Independently, they're all challenging problems, but like taken together, it's really hard. And if you make the comparison with a smartphone developer, so you're a smartphone developer, you really need to care only about your business logic. So you come, you have this small part of the pyramid that you need to care about. But if you're a roboticist, you're out of luck. Even now, it's very hard to have really a readily usable platform where you won't have to maintain all of that by yourself. And it's very hard for startups to do so. So again, the solution comes by more collaboration in the industry, and it's really happening now. So we are heavily contributing to ROS 2, the next generation of ROS. We are building features such as improved quality of service settings, logging system improvements. We ported and we're maintaining ROS 2 on ARM 32 bits. We are also bringing Amazon expertise in terms of development to improve the quality of the code and also the security. So ROS 2 comes with a secure version where the communication between the components is done over encrypted transport layers. Well, we're also contributing to that as well as we authored a ROS 2 threat model to help startups building robotics products have, if you want, a kind of checklist to know what they should care about if they want to design a robot for security. So that's great, but we're not the only one pushing. Something which is also very interesting to see is that there is a real shift in the community. Now ROS 2 has what we call a technical steering committee. It's basically companies which are dedicating at least 2 engineers full-time to develop ROS 2. So, of course, we're doing that, but you can see other big players in this list. ARM is doing that, Bosch is doing that, Intel is doing that, Toyota, Microsoft, and so on. So you can see that all of the community is kind of assembling and aligned behind this platform to try to do something which is really going to shift the state of the ecosystem in the future, which is really having one single place to build reusable robotic components. So how can we help being AWS? So to simplify the development of robots, we have AWS RoboMaker is integrated with Cloud9. So Cloud9 is Amazon Cloud IDE. So it's basically an IDE like VS Code, like Eclipse, like CLion, that you can, in your browser. So you can directly, in one click, provision machines you can use for development purposes, and you connect to this IDE, and it comes with ROS pre-installed. So you go from 0 to being productive immediately instead of having to care about either like installing a Docker image on your local development machine, or like just going through the installation steps one by one, which is time-consuming initially and also to maintain. So obviously, because it's in the cloud, we also have an integration with our like simulation as a service feature. So you can write code in your browser, compile it, bundle it, basically put your code in a tarball, and this is going to get sent, if you would like to our simulation as a service feature, which is then going to run Gazebo on it and make sure that what you wrote actually works in a simulation. Another area of investment for us are cloud extensions. So again, building robots is very hard, it's very capital intensive, and we are trying to lower the barrier to use AWS in your robot application by building open source ROS nodes which can be used to integrate with AWS services. So you can see the list there. Especially, so Amazon CloudWatch is important. So what it allows you to do is basically stream log data to CloudWatch from your robot in real time. It's very important because, again, testing is very hard and time-consuming on robots. So what happened with that is that you can use this data to find faults and issues which happens in your robot in production after the problem happened. So we also integrate with Amazon Lex, Amazon Poly, so to build and offload like your conversational capabilities of your robot, your text-to-speech to the cloud, Kinesis video streams and Amazon recognition, which would allow you to offload everything around object recognition, people recognition, and environment recognition. So all of those features can be easily plugged into robot applications because we released those open source tools, basically like bridging the gap between AWS on one side and ROS on the other side. Another feature that I wanted to talk about today is fleet management. I think it's very similar to what we heard earlier this morning with RTOS. So RoboMaker allows your robot to be integrated with AWS IoT Greengrass. So what happens is that your robot will run the Greengrass agent. And if your robot runs the Greengrass agent, you can register your robot to the RoboMaker fleet management feature. What it gives you is the ability to securely deploy over-the-air updates to your robot. So again, we saw in many cases that it's very hard to reach MVP for robotics companies. And then once you're at MVPs, and there is still a lot to be done to move from having one prototype or one product working in a lab to being able to actually deploy those robots in the field, having hundreds of those, well, and actually starting making money out of this business. And that's where we can help by make streamlining over-the-air updates. Okay, so just to kind of like give an overview of all the features I went through today. So if you look at this diagram, you can see that open source software is at the foundation of what we are doing at AWS RoboMaker. We have ROS 2, we also have Gazebo, And while those open source software are very important so that the community has a platform to collaborate, we also feel that there is a lot of value to be added by leveraging the power of the AWS infrastructure. And so you can see the different features that we built on top of those open source software. So we have cloud extensions for ROS, we have development environment, simulation, fleet management. All of those, in different ways, are basically expanding the capabilities of this software to bridge the gap between having a software which is running fine on a single robot to, lower the barrier to actually build a real robotic product. And in conclusion, what I wanted to say today is that, well, you can try AWS RoboMaker today. All of those features are already launched. We have simple applications which are covering a lot of ground, from a simple hello world to advanced tutorials such as navigation and person recognition. You don't need a robot. You can run all of this simulation in RoboMaker directly. And again, Cloud9 is there to simplify your ROS development. You can get up and running very quickly by leveraging those cloud instances. Cloud simulation will allow you to directly see what your robot application is doing and prototyping and validating quickly without necessarily requiring real hardware. The fleet management is then going to help with the last stage, which is, now that you have your robot application, how can you put that into production and update it over a large number of robots in the field? And if you want to integrate with AWS, we will also make that easy for you. You can directly reuse those open source ROS nodes to leverage different AWS services. And so we're just getting started with those. So we're really looking for community feedback around what kind of other AWS services you would like to use to actually expand the capabilities of your robot. But we already have all of those services covered, and we're really just getting started. So there is our URL there, and I will be tomorrow and on Thursday at the booth if you want to discuss more about RoboMaker. Thank you very much.